Welcome. We are going to obtain the damped natural frequency of a single degree of freedom system with these properties. At first, in Part module, we should click on Create Part. Then in the dialog box, in front of Name, we should type a name, for example, Mass. And from this part, we should click on Point and then Continue. Now we should enter the coordinate of the point, for example 0, 0, 0, and then press enter. Then change the part module to the property 1 and then click on Special and Inertia and Create. In the dialog window, select Point Mass and then click on Continue. We can select a name, for example Set Mass, and then select the point and Done. In the dialog window, in this part, we should type the mass 2 kg and then OK. Then change the property module to the assembly module and then click on Instance Part. In the dialog box, at first click the part and then click on OK. Now change the assembly module to the step module. Next, click on Create a Step. In the window, from the procedure type, select Linear Perturbation and then click on Frequency and then click on Continue. In the window, click on Value and type 3 and then click on OK. Next, click on Create a Step again, and from the procedure type, select Linear Perturbation and then click on Complex Frequency and then click on Continue. In the window, click on Value and type 3. Then click on OK. Now change the step module to the interaction module. Next, click on Special, Springs Dashboards and Create. In the window, click on Connect Points to Ground and then click on Continue. Now click on Sets and in the window, select Mass and then click on Continue. In the dialog window, from this part, select 1 as the degree of freedom of a spring at dashpot and in this part type 4. Then activate this part and type 1. Then click on OK. Now change the interaction module to the job module. Next, click on Create Job and in the dialog window, write a name for the job, for example, Example 1, and then click on Continue. In the window, in the Memory tab, for example in this part, type 100% and then click on OK. Now click on Job Manager. Now in the window, to start running the job, click on Submit and wait for completing the job. As you can see, it has been completed, and in order to open the ODB file and see the results, click on Results. Now click on Results, Step Frame. In the window, select Step 1. As you can see, the undamped natural frequency of the system is this value in Hertz. The undamped natural frequency of the system can be found from this equation, and the natural frequency can be obtained from this equation in Hertz. As you can see, the undamped natural frequency is this value, and the square of omega n equals 2. Now we will compare the results. The natural frequency of the system is this value in Hertz, and the square of omega n equals 2. As you can see, the results are the same. Now, in order to obtain the damped natural frequency, click on Step 2. From the theory, the poles of the system are obtained from this equation. The real part is this value and the imaginary part is this value. As you can see, the imaginary part is the damped natural frequency and can be obtained from this equation. By replacing the values, the damped natural frequency is 1.39 radians per second and the natural frequency is this value in hertz and the square of omega t is this value. Now we will compare the results. The real part is this value. The real part and the damped natural frequency in hertz. As you can see, the results are the same. Thanks for watching the video.